since Tekelec started in Brazil, we start with portability, moving from IAS 41 to GSM, that is portability. So it's signaling. This is what is really strong and growing. As far we have demand for a lot of service, new service, Twitter, things like that. So that improves all demand in terms of traffic. In terms of traffic, we are in this scenario since long, and our platform is really strong. We can grow, we don't have any problem in terms of growing any network in the world. Today, we can, of course, face without any problem this Olympic Games growing. That we know that will be need a strong, very strong growing. So we are preparing for that. No problem. Well, regardless this any kind of migration we are prepared for that. Okay, so since the beginning we are growing, and the evolution of the platform we have moved for the future, regardless is LTE or WiMAX or any other kind of path we take. No problem. Well, in terms of LTE, you mean, or WiMAX? This is what you're talking about?
No, in terms of the migration from traditional TDM to all IP.
Okay, they are doing that, and it's all network today, mobile. By the way, it's SIGTRAN, it's IP. They are implementing that, and our platform is doing that without any problem.
Sure. I mean, I think that generally speaking, there's the whole area of customer experience management. And whether it be smartphones, whether it be SMS, or other types of services, customers really, or say service providers, really need to understand how customers are accessing their services and whether or not they're getting the quality of service that they expect. So really, our IAS system can look at a variety of different services, whether it be plain voice services in a mobile environment. It can look at roaming services and look at whether you're getting the quality of service there from roaming partners as your subscribers roam. It can analyze SMS type services. So really, smartphones are only one type of service that you need to look at from the perspective of customer experience management. In many ways, data complicates things exponentially from a couple of different perspectives. One, it supports many different services. You could be accessing email, you could be accessing the web, you could be downloading content, you could be looking at videos. So not only do you need to look at, in essence, the signaling traffic that's going across the network, things like authentication, but you also need to be able to look into the packets and understand what type of traffic your customers are accessing, or what services your customers are accessing, and whether they're getting the appropriate quality of service. Tomorrow I'll show an example of where customers were doing web browsing and they weren't able to get access to the DNS service, which basically means that really none of their services would work. So it's important on the data side to be able to look not only to look into the packets and understand what's going on, what type of traffic and what types of services your customers are accessing. Our system today is more on the monitoring side as opposed to something that will take proactive action and, for instance, block certain types of traffic. But certainly I think the first step in moving to that type of a control system is really understanding what type of traffic there is on your network. So is there Skype type traffic, or again, is it the type of traffic you're more open to, regular data type services, again, email, web surfing, things that the carriers would probably be more open to. So we focus much more on the monitoring and the troubleshooting side as opposed to the, let's call it the bandwidth management side. So, I mean, we can get the systems up and running relatively quickly, in a matter of weeks, and we've seen carriers be able to recoup some of their investment within a matter of months device. So from that perspective, it can be very quick. Again, some of the measures are more difficult sometimes to put in dollars and cents in terms of, for instance, customer experience management. But certainly, I think by providing a higher quality of service, you're going to reduce churn, for instance, and that can always be a very large cost savings for customers, not to have to go out and reacquire the same customers or acquire new customers for those that are turning off your network. So again, we've seen the system pay back very quickly. The other thing is again, in the examples I'll talk about tomorrow, we, with just monitoring the network for a few days for a trial, were able to pinpoint several different problems that really would have resulted in very poor service for this operator's customers. So they were able to really immediately see a payback and see the value of the system.
Actually, what we see is that SIP is being deployed right now, right? And we took a survey of what are the problems that the customer encounter when they start deploying SIP into the real world, right? SIP work fine in the lab environment, but when you start deploying them in the real world, they run into some real problem. And one of the things that keep coming up as a #1 issue in the deployment is SIP interoperability. To be able to get SIP implementation from one vendor to talk correctly with another vendor. Well, actually, that's a lot of misunderstanding, right? SIP is actually very well defined. Okay, if you look at the IETF specification, SIP defines message structure. It defines the procedure to a pretty well level of depth. Okay, the problem is the interoperability is not really the SIP itself, but how it's being used in the real world. For example, one of the things that we found out in the when we did the problem analysis was that SIP is very well defined, but SIP is based on client and server architecture. Okay, so the client know what the server can do. So most of the time, if the client come from one vendor and the server from the same vendor, then the client know what to ask the server, and server know how to serve the client, right? And it has nothing to do with SIP. So what happened is that when a vendor create client and server application, they put special extension to SIP, so that the client can take advantage of a special function in the server side. Okay, that special header that they created, that causes an incompatibility when you use the client from one vendor with another server from another vendor. So what Tekelec is doing is that we come up with the, we believe that a temporary solution is just a patch. Okay, we need a long-term sustainable solution. So what we do is that we implement what we call SIP mediation framework that reside on the proxy. Okay.
That's the patch or the long-term solution?
No, that is a long-term solution. Okay, so we believe that implementing the mediation framework on the proxy matches the SIP architecture, and it can evolve along as SIP evolve with the IETF. Well, I mean, IMS is just another implementation of SIP. Okay, basically, right. Basically, IMS takes SIP and put a lot of 3GPP specific feature on top of it. Right. We believe that there's going to be a long coexistence between pre-IMS SIP and the 3GPP compliant SIP, which is IMS. So I think they coexisted because they're compatible in a way.
And your proxy would sit between those two to make sure they can communicate?
The proxy can sit within the SIP node within the NGN network, pre-IMS network, as well as between the NGN and the IMS network.